Let's discuss LeetCode problem number 1371. Find the longest substring containing vowels in even counts. But before we discuss, please like, share, subscribe, and hit the bell button for notifications. Also, I have added a lot of quizzes to the community page. Please check it out. Now back to the problem. Given a string S, you need to return like this. You need to return the longest substring like this, which has even number of vowels. It can be 0. Yeah, all of the vowels can be 0, but if they exist, they should exist in even count within the substring. So let's take a look at the solution. I call this as there are multiple ways you can call. I think this one, this problem is like too many patterns you can name it as. But one thing which stuck out to me is that the scene map, once it has the bitmask has been set, you don't update it actually, or you just set and forget. You just use it, and then that's the one thing to remember in this solution, which is unique about this solution. So this unordered map vowel mask is to basically store the bitmask for each of the vowels, and this is the scene map we are talking about in the pattern. Whenever we see a bitmask, new one is seen, we just store the initial position. For scene 0, the mask of 0, we set it to -1, because in scenario like this, right, you just have a string L, mask is 0. So when you see this string, once you set it to 0, minus of -1 becomes length 1. If you don't do that, you will return 0 in this case, and which is incorrect. So mask is the running bit mask which counts the even number of vowels, and max length is the length of the substring. And when you loop over the string, get the current character, and if the current if it matches any of this vowel mask, means it's A, E, I, O, U. So that's the first one here, the key A, E, I, O, U, and that's what we're checking here. If it is a vowel, then you flip it. If it is 0, it becomes 1. If it is 1, it becomes 0 in the mask. Means if you set it, basically means it's odd. If you clear it, if it's 0, means it's even. And now once you do that, then the running mask, you check if it is in the scene map or not. If it is not there, then you set it for the first time. Otherwise, now because you have already seen this bit mask, so the distance from the index in the scene map to the current location is the max length. And we can see that in the example run, and you return the max length at the end. So now let us take a look at this solution. We already seen this one. For this one, when you read the character E, the mask is set as 01001. So we just sent a new mask found. So because it's just a odd number of vowels, so we still haven't updated the max length. When you see the L, so L accounts for odd one because the substring is L. And when you see the E, then you see it when you clear it, and you have seen already 0th thing, bit mask as -1. So that's what basically accounts for ELE. Index is 2, 2 minus of -1 becomes 3, and so that is ELE. And then when we see the fourth character E, it becomes even again, so it becomes LE, and then 4 LeetCode, 2 events, and then this keeps adding, because when you add a consonant, basically you just keep incrementing the substring, because they're not vowels. So and then where are we? So leet m, what is there after that? lithium I basically. So I this is a logging problem actually. Here it is still 5 because you've seen I only once and it becomes a new bit mask. And then when you see the I for the second time, that's when the max length is updated, so it becomes leet mini, and so on and so forth. You go until you get the maximum length as 13, and that's where I think 13 is when it ends at the second O. This is the 13th length. That's it. Comment below if you have any questions. Otherwise, I will see you in the next video. Bye.